Hi everyone, I'm Emily Pinto, and today we're going to talk about Creo Flow Analysis. So we have a short PowerPoint here, and then we're going to get into an example. So the reason why we like to talk about Creo Flow Analysis and why PTC created it, one of the big things is the inability to gain early design confidence and mitigate risk, especially when talking about flow analysis, because it is such a technical, hard to, sometimes often hard to find, a good intuition for, and analysis is very difficult to do. We see a lot of lack of CFD analysis out in the industry, and this often leads to delayed and over budget projects because the flow around your model or through your model really does impact the performance. And if you don't have proper analysis to predict how that's going to go before you prototype your model, this can cause huge delays and costs that are wasted. So we see this a lot in the industry. Another reason why we wanted to provide our customers with a flow analysis solution. Less time, budget, and resources. This is all the things that help you innovate your products, right? You have to have information and insight into how your product's going to perform. And if you have no insight, you end up really delaying things and not being able to spend time on innovation where you're improving your product when instead just trying to get it to a point that works. So this is our solution for Creo Flow Analysis. We wanted to specifically address these issues in particular, as well as support the whole workflow around flow analysis. And this is a really great tool because we've partnered with a best-in-class solution, Sumerix, which powers our Creo Flow Analysis engine to perform really high fidelity, easy to use, right? It's a really great tool. So we're going to talk about the capabilities, and then, like I said, we'll look at an example of this in Creo. So the first thing we like to talk about is that this is easy to use for all engineers, not just specialists that are very experienced in CFD and analysis, because when you have someone who is your day-to-day engineer, flow analysis can be very outside the realm of what people know or are comfortable with. It's one of those solutions or one of those skills that takes a long time to get the hang of. And so Creo Flow Analysis wanted to mitigate that issue and design this specifically for the engineer who is familiar with the Creo layout, is familiar with modeling, maybe has seen some analysis before, but isn't an expert. And Creo Flow Analysis walks you through the workflow and provides you with the intelligence and the skills that are needed to create these high fidelity simulations quickly and easily, even if you don't have that background. So this is a huge benefit of Creo Flow Analysis and using it inside of Creo because it's accessible to the engineer, which is a new idea for flow analysis, right? It typically is difficult to get these high fidelity results. So another big reason why that's possible is the workflow between CAD and CFD. There's a lot of time spent usually in translation to maybe a different group or a different team, a different software where you're running these flow analysis simulations. So with Creo Flow Analysis, again, that's mitigated and you're able to save all that time by having the same model that you're working on be the model that you're running your CFD. And so this is how we incorporate CFD into the design process. You're not just checking something at the end. You're able to incorporate it at good points in your project when you need to look at that flow response and be able to take it into flow analysis, set up a study, quickly find those results, and not have to waste time on translating your model and trying to communicate to someone else exactly what you're looking for. So this is a really seamless workflow between modeling and that CFD. So it's very easy to set up. The flow model creation is one of the great things about Creo Flow Analysis. It will actually generate that mesh for you, generate that internal domain, So you select the inputs, inlets, and outlets, those inputs that you have, and it'll create the internal domain. You can also run external domains, of course, as well, or choose a volume that you'd like to use, and then it'll mesh that. So it uses a really revolutionary type of mesh where it refines in areas that it needs to refine in and leaves it coarse in areas that need to be coarse. And it does this in a way that hugs your model perfectly. And it uses actually much less elements than a competitive solution, and it runs much faster. So not only are you getting higher resolution in all of the areas that are needed, but it's actually going to be speedier than maybe another tool that does something similar. We have rapid simulation turnaround. Like I said, less elements and faster runtimes mean you get your result faster. The engine is very efficient, the meshing is wonderful, and all of this results in very speedy results. You can have those results while your simulation is still running. So before the model converges with our simulation, you can see those results start to pop up and get an idea for where it's going, long before you have that converged answer. And then that converged answer you'll reach in less time, so that you don't have to spend all this time running models. It's not going to take days for you to get these results. We want this to be an integrated part of your design process, so you'll be able to see those results and move on with your design activities, not spending weeks and months waiting for simulation results. These results are also highly accurate. So faster results and efficient meshing does not mean that you're sacrificing any kind of fidelity. The Sumerix is a competitive tool for analysts. It's actually an analyst grade tool. So you're going to have really high fidelity results for a huge range of physics and applications that you can use it for. And all of this, of course, with it, your engineer will be happy with it, and are going to be as high fidelity.
Excuse me, Emily. I think you cut out on this slide a little bit. If you want to, recap that.
Okay. Yep. So the results are highly accurate, right? This is a high fidelity solution. It's analyst grade. It's an analyst grade tool. So you're going to have really accurate results for a huge range of physics. So you can represent your simulation your situation perfectly with the simulation. So this is something that, though it's very easy for an engineer to use, an analyst would be happy using as well. And then you get all the benefits of it being within Creo, but you don't have to sacrifice fidelity. Okay, so today we're going to look at an example on this Polaris snowmobile. This is a customer model, right? It's created in Creo. It's a good example of maybe a type of flow analysis that you would want to run. So the analysis we're going to look at today is run on this heat exchanger. And we can see the inside of that if we do a cut section, right? It's just this thin body, and we're going to look at the channels that are inside. So this is where our fluid is going to flow. Now, to get to Creo Flow Analysis, you can imagine you're designing this heat exchanger, and you want to know how it's going to behave, if it's an efficient one. So in order to optimize this, you need to know a lot of those different analysis results that would be hard to get otherwise. And we have up here in our Applications tab a flow analysis in our simulation, which opens our toolbar. Now, again, this is going to be very easy to set up and run. It is a high fidelity analysis, so you will have a lot of options to get very granular and into the details if you want to. Right, this is going to have all the buttons that an analyst would want, but if you'll watch carefully, it's fairly simple once you get the hang of the workflow here. It's going to be really straightforward. So for a new project, you just move left to right. And we can see here that the first thing to do is create the fluid domain. Now, there are a couple of different ways you can do that. You can select a simulation domain, you can split a domain, you can choose an external, but here it's going to ask us for the faces and holes that we want to select as our inlets and outlets. Now, we could have it auto select these and it'll find all the holes, or you could say, no, I only want to look at these. I want this to be an inlet and this to be an outlet. So these are going to be the boundaries of my internal fluid domain. We can add that to the simulation. We see internal selected, so that looks good. We have all of the openings that we want to consider. Now, one tool we have is to show the CAD bodies. We can turn that off. So this is actually showing the flow analysis bodies. You'll see that's highlighted up at the top. So we know that this has created that flow analysis body, that internal domain. It's a solid part. And then we can select the domain. So we have this as the fluid domain, but we need to tell it where that solid domain is. So we just select the heat exchanger that we're using, that model that we brought in, and we'll say that that's our solid domain. And now we can choose the material for each. So here we have our fluid domains listed. We just have the one, that heat exchanger that we created. And you can choose a fluid. You can always add custom materials to this as well. We have an extensive materials library, but if you have one that you work with or parameters that are specific to you, you can change those. Our solid domain, right, works the same way. You can always add custom. And now after materials, the next button we have is the physics module. This is where we tell Creo exactly what we want to incorporate. Now we have different levels of Creo Flow Analysis packages, and that would determine which physics you have available to you. So if you're just running pretty straightforward simulations, you may just need that the standard package. But if you're going to get into all sorts of more complicated physics and analyses, then those would be available to you here. And whichever package you have, the options that are available to you would show up here in this physics module. So the workflow is the same for any of these. It's just a matter of choosing the physics you'd like to include. So we almost always include turbulence. Definitely going to include heat, especially since this is a heat exchanger. We'd like to include streamlines as well. We can always calculate those later, but it's good to have those up front. So now that we've made it through our operations, we can start looking over in the model tree. And this is where we're going to put some of the parameters in. Now that we have all the components of our flow analysis, we have the domains, we have the physics, we can start putting in those details. So in the domains, we can see the heat exchanger, and down below we get all of the different options that we have for defining this. So you can have constant density, the flow, and the more things of this that you would add depending on what you have selected down here is going to be you're going to get more options for different things. So for example here, your output, you want a max temperature, right? So then it'll give you that option. We can plot those. We have an XY plot that you can use. So that's going to be useful when we start watching our results. Now for the boundary conditions, we can see specified temperature, specified flux, and then it gives you the options for that selected one. Like I said, you get options as needed based on what you already have selected. So the flow, right, the flux gives you inflow and the velocity profile. Streamline, you get some streamline options. For the outflow for this boundary condition, we can choose from our different flow options. So this is going to be specified pressure. Then we get our pressure options. We'll have 0 pascals. It's good for us. And then the heat exchanger is one of your boundaries. So you can choose the heat, what you want that heat exchange coefficient to be, what you want the convection coefficient to be, the ambient temperature. And then we're ready to generate the mesh. So our mesh is very quick. You see that it meshed this in no time at all. And when you take a look at it, you can turn the mesh on. So the mesh is just an entity over here now that you can view. So it's our grid. You'll see that it refines in areas that need to be refined and keeps it coarse in areas that don't. This is a wonderful tool, especially for maybe engineers who don't have a lot of analysis background. This mesher gives high quality results. There's no issue with artifacts of the mesh showing up as stresses or heat or anything like that. stresses, different analysis results, you're going to have a really high quality mesh with the auto mesher. You do have options to manually control some of those, of course, but it should work really well. So here we have the run flag that we can look at. And with our advanced package, we actually can see these results as they're still being calculated, right? So we can take a look at that streamline, we can animate it, we can see the color is the temperature over on the side. We have our XY plot and our residual down at the bottom. That's from that XY plot panel. And your results are all going to be entities in that model tree, in the simulation tree. So that's where you're going to manage all of the different entities you have is over in that tree. Now that our solution has converged, we can start looking at the simulation results a little bit more detailed. You can control the animation, of course, control what you're viewing. We can control the variable. So we have that long list of variables. We can look at pressure. You'll see the legend changed. We can also look at things like enthalpy, energy, vorticity, velocity, where we have a lot of different solutions that you can view here. And you can view them for all of the different entities in your domains, right, what you're calculating. So you can look at it for the flow. You can look at it for the simulation body. You have your derived surfaces. So you can derive things from here as well. Here you have this cross section that you can move YZ direction. And then you can pick a point that you want to look at it, or you can scroll it through. Another way to view that would be the ISO surface. So you can choose an ISO surface for temperature. You want your variable to be temperature, and then scroll through and it'll show you all of those different surfaces for the different values. You can also look for values if you want to put in your value as a parameter, and it'll show you all of the areas that match. Now, once you've viewed your results and you have a good idea for what that looks like, maybe you want to make a change. So you go back to your modeling tab. It was really that quick, right? You just click out of flow analysis, you're right back to your modeling environment. You make changes to your model. For example, here, the internal channels have changed. Maybe use your additive manufacturing lattices in there. And then all you have to do is reopen that project and update it. So this update project means that it gives you an info. It says all the current fluid domains will be deleted, which just means that you're going to have to rescan your model. So everything is saved except for the inlet and outlet geometry. So the parameters for the inlet and outlet are all saved. It's just here you have to reselect those because it wants to make sure that there aren't any changes to the domain. Because you've made changes to the model, you want to make sure that you haven't forgotten anything, that you're not accidentally rerunning on the same domain, but actually you've added an outlet somewhere, or you've added an inlet. So it just checks for any new holes that you might have and confirms that you still want to use that same outlet and inlet. And from there, all of your project parameters, everything that you have is saved. So it only takes a second to review that domain, the mesher, auto updates, and you can see your results again. So here's the streamline we're looking at. You can tell that it's changed quite a bit. Our results are still converging, but we can see them here with that in that advanced package. So this is the temperature, and we're already starting to get a good idea of how this is different from our first design. So again, a model like this, right, it's going to run much faster than a similar fidelity model in maybe a competitive solution because of the way the engine is working in the background. Cimerix is best in class, even in terms of analyst level software, right? Analyst quality software. Cimerix is really a competitor best in class solution. So all of this is going to be high fidelity results, but in a much shorter amount of time and much more easy to set up than maybe using a full-blown analyst user interface, right? So designed with Creo users in mind. So just going to wait another minute for this simulation to converge. Okay. So here, now that our solution is finalized, we can look at the different options. So maybe we want to investigate the pressure, make sure that there hasn't been a change to it, take a look at our heat exchanger, make sure that there hasn't been any problems caused by this new geometry, and that it's more optimized to see, okay, well, what design should we go with? Are we moving in the right direction? Is this going to meet all of our customer requirements? Is this going to behave properly out in the real world? And you're able to use all of this information to let you know how that simulation will look. So here we can see this ISO surface. There's a lot more volume on that now, so that's a good indicator that that level is going to work well. We do like to talk about what our customers have said about this flow analysis tool, and the value here, it's going to lower your life cycle costs. You're not prototyping to figure out what's going on, and you're not wasting so much time translating to different softwares or to an analyst team. So you're able to get results much faster, which means you're able to do them more often. And so the life cycle cost there, you're not going to have to do late stage rework. You're going to have a better idea earlier on, especially before prototyping, of exactly how this will behave for the situation that you have it in. Reduce cost and time to market, yep, and increase product quality and innovation. These are all big ones for customers that, when flow analysis is integrated into their process, you're able to get to market faster with fewer iterations, and fewer iterations are both timely and costly. So all of this helps you improve your product quality and innovation and still get to market on time and finish your projects within the deadline. But now you're not spending all of your time just trying to put out fires. You're actually able to investigate innovative ideas and higher quality solutions to some of those problems that might come up. So this is a really useful tool pretty much across the board if flow analysis is an important part of your model's performance.